All right. So now, once that we introduce the multiplication rule, one of the first thing that we can think is the concept of permutation. So let's say that we have a set of objects that have an ordering um, in a particular row. So, for example, the set of elements that are composed with the letters A, B, and C. If we take those A, B, and C and we arrange them in a row, we can have six possible permutations. Those possible permutations are going to be ABC, ACV, BCA, BAC, CAB, and CBA. So as you can see, it's about the ordering. Letter A first in variation of the other two, letter B first, variation of the other two, letter C first in the variation of the other two. In general, the rule is going to be that for a set of n elements, where we have this, here we have three elements only, but for a general set of n elements, we're going to have n factorial permutation of that particular set. So in this scenario, because we have three elements, so that's going to be 3 factorial. And 3 factorial, do you remember, is 1 times 2 times 3, which is 6. And so that counts the whole amount of elements. Now, we can do more complex arrangement with that. For example, we can take the letters in the words winter and find how many ways we can arrange those letters. And so, of course, now here we have 6 possible letters that are different, which is very important. And then because of we're doing permutations here, then we're going to have 6 factorial as the number of ways that we can arrange this. And so notice that 6 factorial is a very big number. This is 1 times 2 times 3 times 4 times 5 times 6. This whole thing is 6. So 6 by 4 is 24. 24 by 5 is 120. And 20 by 6 is 720. So we're not going to list all the possible permutations like we did with the 3 letters case, because it will take us 720 different arrangements. So we just want to know how many they are, but we don't want to write them. Now for number 2, another example is, well, let's assume that we fix some of the letters. So we're going to fix WE, and they need to remain next to each other. We can vary everything else, but we can kind of move everything else, but WE is going to be next together. So for example, we're going to have WE together, and then we can have NTER. But you can also have the scenario where you can have like NTWI fix, and this is different, right? So you can have this situation. So WE is like it's like you have it as a single element here. So we're just permuting WEs as a single thing, N as a single thing, T as a single thing, E as a single thing, and R as a single thing. So we're just really permutating 5 things. So this is going to be 5 factorial. Okay? This regardless of whatever they are, they're objects, and we're just moving those objects in a particular way. Since we're keeping WI together, that's just a single object. So this is going to be 5 factorial. We already saw it. It's going to be 120. It's reaching to this point. And of course, with this type of arrangement, we can also do probability. So if we have the letters of the word winter and are randomly arranged in a row, what is the probability that the letters WI remain next to each other in order as a unit? So we want to know the probability of what happens here in the overall case. So this will be the probability of WI, and I'm gonna put it here, WI bar. So we know that is that where we're keeping WI together, and so that's the number of permutations that we have with the scenario of wi together over the number of total outcomes. And so from here we know that this is 5 factorial over 6 factorial, which is just going to be 5 factorial over 5 factorial times 6. So this is actually 1 over 6. We get to cancel this. Okay. Now with permutations in general, we can use permutation of a specific number of elements. We can permutate just a certain number of elements. So for example, given the set ABC, there are 6 ways to select 2 letters from the set and write them in order. So notice that we're not using the whole set. We're just picking from that particular set 2 of those letters and looking for the possible ways to permute those different letters. So we have AB, AC, BC, BA, CA, CB. So in this case, each of this ordering of the 2 elements of ABC is called a 2 permutation of ABC. And in general, an R permutation of a set of n elements is an order selection of R elements taken from the set of n elements. And we call this permutation of nr. And so by that permutation is just going to be really the multiplication from n up to the n minus r minus 1 element. And that's going to be characterized by n factorial over n minus r factorial. So for example, in how many ways can we pick 3 letters of the word bird and chosen and written in a row? So of course, we have 4 letters here. This is B, I, R, D. This is our set, comparing with this. And now we're going to pick 3 letters out of this. So we're doing a permutation of 3 letters out of a set of 4. So we get 4 factorial over 4 minus 3 factorial. So this is 4 factorial over 1 factorial, which is really just 4 factorial, because 1 factorial is just 1. And 4 factorial is, of course, going to be 6 by 4, so it's 24. So we have a total of 24 possible. Now, how many different ways can this be done if the first letter must be B? Okay. And so this is pretty much just we have bird, right? But we're fixing B, so B is always gonna be fixed, and what we can change is the rest of the letters. So we can have bird, but we can also have BIDR, but we can also have BRID, BRDI, BDIR, and BDRI. So we're just rearranging really these 3 letters. So of course, this is really like the first scenario that we have, and is in how many ways can we really arrange 3 letters, because the first one is not really moving. The one that is moving is the other ones. So this is just pretty much producing you 6 outputs, and it's because we're moving 3 letters, right? We're moving 3 letters. So from out of the 3 letters that we have, we're picking we're doing a permutation of let me erase this here. we're just doing the permutation of 3 letters over 3 positions, really. And so this ends up being 3 factorial over 3 minus 3 factorial. And so this is 3 factorial over 0 factorial, which is 3 factorial over 1, or 6. And so this is going to give me the 6 possibilities that we have over here. Okay. Notice that in this, we don't really care about, we care very much about the order. So the order is important for permutations. Okay. In the next week, we're gonna probably see the other way, that is combinations. And for combinations, we might be we might not care about the order. In this, we do care about the order that they are. Okay. All right. So this is the end of the summary. Make sure to go over the practice and practice with both the R permutations and the regular permutations.